Hello, this is Dr. Moultrie, and welcome to Corporate Finance, where we're discussing Chapter 5, which deals with interest rates. Chapter 5, interest rate. This is part 2 of Chapter 5. So in this video, we will discuss application, discount rates, and loans. Discount rates and loans. But before we move on to that, here's a problem. You have decided to refinance your mortgage. You plan to borrow whatever is outstanding on your current mortgage. The current monthly payment is $2,356, and you have made every payment on time. The original term of the mortgage was 30 years, and the mortgage is exactly 4 years and 8 months old. You have just made your monthly payment. The mortgage interest rate is 6.375 APR. How much do you owe on your mortgage today? How much do you owe on your mortgage today? Be careful not to round any intermediate steps less than 6 decimal places. So we're trying to find out the amount you would owe today. So first of all, to find out what is owed for the remaining period, we have to compute the present value of the remaining payments. To do this, we first have to compute the discount rate by using the loan interest rate, or the APR. And that formula is R equal APR over M, where APR is the loan interest rate and the letter M is the number of compounding periods per year. Therefore, when we plug in those numbers, we should come up with this. R equals 0.06375 over 12. And you should come up with this answer at the rate of 0.53125%. So the monthly discount rate is 0.53125%. Then we have to calculate the present value of the remaining payments using this formula, where the letters PV, which is present value, is the loan balance. The C that you see here would be the monthly payment, and the letter R would be the monthly discount rate, and the letter N is the number of periods. So that's the formula. So when we plug in those numbers, we should come up with this information. And I'm not going to read it out. It's there for you to see. And when you do your calculation, you should come up with this answer. So the amount you owe today is $354,899.99. Here's another problem. The firm is purchasing a new telephone system that will last for 4 years. You can purchase a system for an upfront cost of $150,000, or you can lease the system from the manufacturer for $4,000 paid at the end of each month. The lease price is offered for a 48-month lease with no early termination. You cannot end the lease early. Your firm can borrow at an interest rate of 6% APR with monthly compounding. Should you purchase a system outright or pay $4,000 per month? Let's see. The cost of leasing the system is a 48-month annuity of $4,000 per month. We can compute the present value of the lease cash flows using the annuity formula, but first we need to compute the discount rate that corresponds to a period length of 1 month. To do so, we convert the borrowing cost of 6% APR with a monthly compounding to a monthly discount rate using equation 5.2. Once we have a monthly rate, we can use the present value of annuity formula in equation 4.5, which we all discussed in the previous videos, to compute the present value of the monthly payments and compare it to the cost of buying the system. In equation 5.2 shows, as equation 5.2 shows, the 6% APR with a monthly compounding really means 6% over 12 equal 0.05% every month. The 12 comes from the fact that there are 12 monthly compounding periods per year. Now that we have the true rate corresponding to the stated APR, we can use that discount rate in the annuity formula, 4.5, to compute the present value of the monthly payments. And here it is. You have the present value equal 4,000 times 1 over 0.005, 1 minus 1 over 1.005 to the 48th power, all in parentheses, equal $170,321.27. To use a financial calculator, this is what you would input into the calculator. And this is the Excel formula that you would use if you were going to use an Excel spreadsheet. Thus, paying $4,000 per month for 48 months is equivalent to paying a present value of $170,321.27 today. This cost is $170,321.27 minus $150,000 equal $20,321.27, higher than the cost of purchasing the system. So it is better to pay $150,000 for the system rather than lease it. One way to interpret this result is as follows. At a 6% APR with monthly compounding, by promising to repay $4,000 per month, your firm can borrow $170,321 today. With this loan, it could purchase the phone system and have an additional $20,321 to use for other purposes. Here's another problem. Example 5.2a. Your firm is purchasing a new fleet of trucks that will last for 6 years. You can purchase a system for an upfront cost of $500,000, or you can lease a system from the manufacturer for $8,000 paid at the end of each month. The lease price is offered for a 72-month lease with no early termination. You cannot end the lease early. Your firm can borrow at an interest rate of 6% APR with monthly compounding. Should you purchase the system outright or pay $8,000 per month? Here's a solution plan. There's a timeline. The cost of leasing a system is a 72-month annuity of $8,000 per month. We can compute the present value of the lease cash flows using the annuity formula, but first we need to compute the discount rate that corresponds to a period length of 1 month. To do so, we convert the borrowing cost of 6% APR with monthly compounding to a monthly discount rate using 5.2 equation formula. Once we have a monthly rate, we can use the present value of annuity formula and 4.5 to compute the present value of the monthly payments and compare it to the cost of buying the system. To execute, as formula equation 5.2 shows, the 6% APR with monthly compounding really means 6% over 12 equals 0.5% every month. The 12 comes from the fact that there are 12 monthly compounding periods per year. Now that we have the true rate corresponding to the stated APR, we can use that discount rate in the annuity formula 4.5 to compute the present value of the monthly payments. And here we're going to execute using a financial calculator. Of course, what you see there is the information that you would input into the calculator. And at the bottom, if you're using an Excel spreadsheet, this is the formula that you would use to solve that problem. So to evaluate, thus paying $8,000 per month for 72 months is equivalent to paying a present value of $482,716.11 today. This cost is $500,000 minus $482,716.11 equal $17,283.89 lower than the cost of purchasing the fleet. So it is better to lease the fleet for $8,000 per month than to pay $500,000 for it. Discount rates and loans. Here we are in 5.2 again. Discount rates and loans. Numerous loans, including mortgages and car loans, they involve monthly payments and are quoted based on an APR with monthly compounding. Now, these loans, known as amortizing loans, require monthly payments covering both interest and a portion of the loan balance. Each monthly payment remains consistent, right? And the loan is fully repaid with the final installment. For instance, a typical new car quoted at a 6.75% APR for 60 months. You're purchasing a new car, and the APR is 6.75%. If the compounding interval isn't explicitly stated, it aligns with the payment frequency, typically 1 month. So in this scenario, it implies 60 equal monthly payments calculated using a 6.75% APR with monthly compounding. Viewing the loan from the bank's perspective, it reveals an exchange. The bank provides cash to you today for your car purchase. And in return, you commit to making 60 equal monthly payments. Now, this arrangement is viable if the present value of your future payments, discounted at the loan's interest rate, equals the cash amount the bank is providing. So to compute the loan payment, we're going to use the formula in 4.9 to find C. First, find the corresponding monthly discount rate. We know it's 6.75% APR over 12, which is months, is equal to 0.00565. Again, we know that every month your loan payment covers both interest and a portion of the principal. And it chips away at the remaining amount you owe. So as the loan balance diminishes monthly, the accrued interest on that balance also decreases. Consequently, while your payment remains consistent throughout the entire 60-month duration of the loan, the portion allocated to cover interest gradually diminishes, allowing the remaining part to contribute more significantly to further reducing your principal. And you can use a financial calculator to figure it out, or of course, use Excel, where you will input the formula in the spreadsheet. Again, as we discussed earlier, we know that a lot of loans, like mortgages and car loans, you do have monthly payments, and they are expressed with an APR incorporating monthly compounding. Now, these loans fall under the category of amortizing loans, where each monthly installment covers, of course, both interest on the loan and the principal, which is the portion of the loan balance. Here in this example that you see here, which is labeled A, so I'll call it just what the book has, panel. In panel A, you see where they're illustrating this effect of a principal and interest loan, right? Here, in the red, you see where the loan, well, in panel A, you see where in the red, it's actually the interest payments, and the remaining portion, which is in the blue, is the principal payment, is the remaining principal payment. In panel B, we can see the impact on the outstanding balance or the principal of the loan. You also can see that as the balance decreases or diminishes, the portion of the payment required to address the interest on that balance also decreases. So this in turn enables a greater portion of the payment to be allocated towards reducing the principal balance. So for your initial payment, as in the previous screens, you saw that the payment was $590 and 50 cents. Yes, $590.50. And there was $168.75. Right? So the $590.50 was the principal payment, or really the initial payment, and the $168.75 is actually the interest payment. So it leaves $421.75 to deduct from the principal. So what I'm saying is the car payment, which was $590.50, out of that $590.50, you have $168.75, which will be going towards interest, and the $421.75 will go to your principal payment. So when that is deducted from your balance, it will leave you a new balance of $29,578.25. Remember, the car loan was for $30,000. Let's go back to it so you can see. There's the $590.50 that I was talking about. And here we're talking about the $30,000 car loan with 6.75% APR for 60 months. Okay. All right, so here we have another problem. Let's say that you are now 3 years into your $30,000 car loan from the previous section, and you decide to sell your car. When you sell the car, you will need to pay whatever the remaining balance is on your car loan. After 36 months of payments, how much do you still owe on your car loan? After 36 months of payments. Remember, in the previous section, it was 60 months. Let's go back to make sure. Yep, 60 months. Okay. So how much do you owe? You made 36 payments. So that means you have 24 payments left, which is what, 2 years? Okay. So we have already determined that the monthly payment of the loan is $590.50. The remaining balance on the loan is the present value of the remaining 2 years, or 24 months of the payments. We can just use the annuity formula with the monthly rate of 0.5625%, a monthly payment of $590.50, and 24 months remaining. So to execute, the balance with 24 months remaining equal $590.50. And then when you compute the formula, you would come up with $13,222.32. So after 3 years, you owe $13,222.32 on the loan. And the next slide, you'll see how you can actually use the financial calculator to arrive at that answer, or use the Excel formula to also arrive at that same amount. However, there's going to be some issues with rounding. Okay. Whereas if you use a calculator, you arrive at $13,222.32, right? And with the Excel, oh, let's see, Excel, you would come up with the $13,222.56. Okay, so you could use, so both of these are actually ones that you would use the financial calculator, okay? So in this first example here, it shows where you input the information, 24 months, and then you have the interest rate. Then you have the payment, the $590.50. You come up with the $13,222.32. So the difference between this one and this one is that this is the 24 months remaining, and this is the 36 months. To evaluate at any point in time, including when you first take out the loan, you can calculate the balance of the loan as the present value of your remaining payments. Recall that when the bank gave you $30,000 in the first place, it was willing to take 60 monthly payment of $590.50 in return only because the present value of those payments was equivalent to the cash it was giving you. Anytime that you want to end the loan, the bank will charge you a lump sum equal to the present value of what it would receive if you continued making your payments as planned. As the second approach shows, the amount you owe can also be thought of as a future value of the original amount borrowed after deducting payments made along the way. Okay, here we have another problem. Let's say that you are now 10 years into a $200,000 mortgage at 4.80%, or should I say 4.80% APR, originally for 360 months, and you decide to sell the house. When you sell the house, you will need to pay whatever the remaining balance is on your mortgage, which we all know. After 120 months of payments, how much do you still owe on your mortgage? Let's see. First, we must determine the monthly payment. You have 0.048 over 12 equal 0.004. The remaining balance of the loan is the present value of the remaining 20 years, or 240 months of payments. We must just use the annuity formula with the monthly rate of 0.4%, a monthly payment of $1,049.33, and 240 months remaining. After 10 years, you will owe $161,694.73 on the loan. And below is the formula that you would use to arrive at that answer. Here you see an example, or An example of how you would actually enter the information into a financial calculator. And below is the formula for using Excel spreadsheet. You could also compute this as the future value of the original loan amount after deducting payments. Again, this is what you see is the financial calculator information, and at the bottom is the formula for the Excel, using Excel spreadsheet. Anytime that you want to end the loan, the bank will charge you a lump sum equal to the present value of what it would receive if you continue making your payments as planned. As the second approach shows, the amount you owe can also be thought of as the future value of the original amount borrowed after deducting payments made along the way. And I am stopping here. So this is the end of the lecture. Thank you for watching.